Welcome back. There's a lot of exciting material to go over this week, and one of the first topics that Mike will share with you in a little bit is a deep dive into how transformer networks actually work.
Yeah, so look, it's a complicated topic, right? In 2017, the paper came out, Attention is All You Need, and it laid out all of these fairly complex data processes which are going to happen inside of the transformer architecture. So we take a little bit of a high-level view, but we do go down into some depths. We talk about things like self-attention and the multi-headed self-attention mechanism, so we can see why it is that these models actually work, how it is that they actually gain an understanding of language.
And it's amazing how long the transformer architecture has been around, and it's still state-of-the-art for many models.
I remember after I saw the transformer paper, when it first came out, I thought, yep, I get this equation. I acknowledge this is a math equation, but what's it actually doing? And it's always seemed a little bit magical. It took me a long time playing with it to finally go, okay, this is why it works. And so I think in this first week, you learn the intuitions behind some of these terms you may have heard before, like multi-headed attention. What is that, and why does it make sense? And why did the transformer architecture really take off? I think attention had been around for a long time, but I actually thought it was one of the things that really made it take off was it allowed attention to work in a massively parallel way. So it made it work on modern GPUs and could scale it up. And I think these nuances around transformers are, not well understood by many. So looking forward to when you deep dive into that.
Absolutely. I mean, the scale is part of it and how it's able to take in all that data. I just want to say as well, though, that we're not going to go into this at such a level which is going to make people's heads explode. If they want to do that, then they can go ahead and read that paper too. What we're going to do is we're going to look at the really important parts of that transformer architecture that gives you the intuition you need so that you can actually make practical use out of these models.
One thing I've been surprised and delighted by is how transformers, even though this course focuses on text, it's been really interesting to see how that basic transformer architecture is creating a foundation for vision transformers as well. So even though in this course you learn mostly about large language models about text, I think understanding transformers is also, helping people understand this really exciting vision transformer and other modalities as well. It's becoming a really critical building block for a lot of machine learning.
Absolutely.
And then beyond transformers, there's a second major topic that looking forward to having this first week cover, which is the generative AI project lifecycle. I know a lot of people are thinking, boy, there's all this LLM stuff, what do I do with it? And the generative AI project lifecycle, which Ante will talk about in a little bit, helps you plan out how to think about building your own generative AI project.
That's right. And the generative AI project lifecycle walks you through the individual stages and decisions you have to make when you're developing generative AI applications. So one of the first things you have to decide is whether you're taking a foundation model off the shelf or you're actually pre-training your own model. And then as a follow-up, whether you want to fine-tune and customize that model maybe for your specific data.
Yeah, in fact, there's so many large language model options out there, some open source, some not open source, that I see many developers wondering which of these models do I want to use? And so having a way to evaluate it. And then also choose the right model sizing. I know in your other work, you've talked about when do you need a giant model, 100 billion or even much bigger versus when can a 1 to 30 billion parameter model or even sub 1 billion parameter model be just fantastic for a specific application.
Exactly. So there might be use cases where you really need the model to be very comprehensive and able to generalize to a lot of different tasks. And there might be use cases where you're just optimizing for a single use case, right? And you can potentially work with a smaller model and achieving similar or even very good results.
Yeah, I think that might be one of the really surprising things for some people to learn is that you can actually use quite small models and still get quite a lot of capability out of them.
Yeah, I think when you want your large language model to have a lot of general knowledge about the world, when you want it to know stuff about history and philosophy and the sciences and how to write Python code and so on and so on, it helps to have a giant model with hundreds of billions of parameters. But for a single task like summarizing dialogue or acting as a customer service agent for one company, for applications like that, sometimes, you can use 100 billion, hundreds of billions of parameters models, but that's not always necessary. So lots of really exciting material to get into this week. With that, let's go on to the next video where Mike will kick things off with a deep dive into many different use cases of large language models.